This is a review of graphing inequalities in two variables prior to doing graphing systems of inequalities. So in this case, y is greater than or equal to x minus 5. Your m is 1 and your b is negative 5. Plot a point at negative 5, and your slope of your line will rise positively. So you're going to go up 1 over 1, up 1 over 1, and come back and go down 1, back 1, down 1, back 1. Now, this is going to be a solid line because it's greater than or equal to, so we're going to draw a nice long line. Now we need to determine where to shade it, so we're going to choose the point 0, 0, because 0, 0 is not on the line. So 0, 0, we substitute 0 in for the y right here. Greater than or equal to, the x is also 0, 0 minus 5, so 0 is greater than or equal to negative 5. And since 0 is greater than or equal to negative 5, that's true, then it is a solution. And so we are going to shade essentially above and to the left of the line. Okay, you have a couple of other very interesting lines that can be graphed in inequalities. Those lines are x lines and y lines. So if you have, let's start with the y line, because that one makes a little bit more sense to a lot of students. If we start with the y line, you can see the slope-intercept form is y equals mx plus b. Well, if its y is less than 4, that means that only your b is left. Well, in order for your b to be left, you would have a 0m, so your slope would be 0. So what you're saying here in this equation is that m equals 0, and a 0 slope is a horizontal line. So whenever you have 0 slope, it's going to be a horizontal line. So this is y is less than 4. So we're going to go ahead and do a horizontal line at 4, and I'm going to tell you another way, besides the way I just showed you, that you can tell how to graph this. It's a broken line because it doesn't have an equal to in it. So we've got this y is less than 4. Now, we could also just say y lines cross the y-axis. The key word there is cross. So this y line will cross the y-axis. Well, the only kind of line that can cross the y-axis, again, the key word here is cross. The only line that can do that is a horizontal line. Now, we're going to finish up with this. We need to be shading because it's an inequality. It's not an equation, it's an inequality. And we're going to go ahead and, let me bubble this. Let's get this so it's just all off by itself. We're going to choose the ordered pair 0, 0. So here's 0, 0. I always like students to at least plot the point, maybe even write 0, 0. You're trying to determine whether you should shade it below the line or above. So we plug in 0, 0. There's no x value, so we have y being 0 is less than 4. 0 is less than 4, so that's true. And if it's true, then it is a solution, which means that you shade on the side that has 0, 0. Now, shading should not be an art project. It should just show that all the ordered pairs below the line, not on the line because it's a dashed or broken line, all the ordered pairs below the line are solutions. Now, let's do this other type of line, which is an x is greater than or equal to negative 2. Now, x lines don't fit into the idea of y equals mx plus b very well. So we're just going to use this idea. If a y line crosses the y-axis, then an x line would cross the x-axis. So if a y line crosses the y-axis, then an x line has to cross the x-axis. Well, the only kind of line that can cross the x-axis, is a vertical line. Okay, so again, that keyword cross, an x-axis. X lines cross the x-axis, y lines cross the y-axis. This is going to be a solid line, and it's going to cross the x-axis, which will mean it's a vertical line. Okay, so it's going to have to be, let's try a different color here, a vertical line if it's crossing the x-axis, whereas a y line crosses the y-axis, so it's a horizontal line. Okay, so we are going to go to -2 and a vertical line. This time it's going to be solid because there's an equal to with your greater than. It's greater than or equal to. Now we need to determine whether we're going to shade to the right or to the left of this vertical line. We're going to use 0, 0. I like students to at least plot the point so they can see it. It's not even helpful to write that in. So we're going to substitute in the x value that's 0. So 0 is greater than or equal to -2. That is true, which means that it is a solution. And if it is a solution, then it is in the shaded area. The shaded area shows your solutions. It doesn't have to be fancy. Just make sure that people can tell you're shading it. Okay, now we're going to go ahead and do, this is graphing, let's go ahead and write that this is graphing linear inequalities. And although you can't see the two variables here, we're graphing in linear inequalities in two variables. But because we know that the problem we're looking at could be in two variables, it's on a coordinate grid versus a number line. So x is greater than or equal to -2 in the context of graphing linear inequalities in two variables is on a coordinate graph, and it's a vertical line. The graph of y is less than 4 in the context of graphing linear inequalities in two variables, usually x and y, would be on a coordinate graph. It's a y line, so it crosses the y-axis, making it a horizontal line. Okay, moving on to systems. Okay, we've reviewed graphing a linear inequality in two variables, along with the special kinds of graphs when you have x and y lines. Now we're going to graph a system of linear inequalities. This will be chapter 4.2. And so we have x is greater than -2 and y is less than or equal to 4. So we know this is in the context of a linear inequality in two variables, so it's going to be on a coordinate graph. X lines are going to cross the x-axis. If it crosses the x-axis, it has to be a vertical line. Okay, let's go ahead and do that. So we've got -2. It's going to be a broken line because it doesn't have an equal to sign. That's one of your graphs. Now, we are going to graph both lines before we decide where we're going to shade. The next line is a y line, and y lines cross the y-axis. Which means they have to be a horizontal line. All right, so we're going to have a solid line for this because it has the equal to at 4. And so we're going to go 4 straight across. Oh, let me do a different color. It's helpful to see the different colors. Remember, your brain likes color, so whenever you can use it, use it. Okay, so now not all of these things are solutions. We have to figure out what is solutions for both. Please note that only points on the solid line would be solutions. Any points that fall on the broken line are not solutions of the equation. We're going to go ahead, since neither line passes through 0, 0. Let's use a different color. There's 0, 0. Since neither line passes through 0, 0, we'll go ahead and use that. So our first step is for the blue line, or the red line, which is our, no, excuse me, this one, x is greater than -2, my fault. X is greater than -2. We're going to substitute in the x value of 0. 0 is greater than -2. 0 is greater than -2, so true, which means it's a solution. Now, you don't shade yet. You just find the proper line. This is the -2. Let's actually write which line this is. This is the x is greater than -2 line. And so you go to this line, you shade on the side. You actually put x's on the side that 0, 0 is, because eventually you may be shading. You don't know where you're going to be shading, but you'll be shading somewhere on this side of the red dashed line. So all I do is put X's all the way up and down. Now the other line, you have to choose 0, 0 for both lines, is y is less than or equal to 4. Substitute in the 0 from the y position. 0 is less than or equal to 4. That is true. If it is true, it is a solution, which means you need to put X's on the side of that line that includes 0, 0. So this is the side, the below part includes 0, 0, so we put X's all the way across. Don't do any shading yet. Your shading occurs where these intersect. There's no intersection over here, there's no intersection right here, but right here the blue, let me get a bigger pointer. The blue comes along, intersects with the red. So it's this part, including 0, 0, that you're going to shade. Let's go ahead and just get this. Let's use a different color. We're going to shade the side where the X's are that include 0, 0. So this would be your solution. Any ordered pairs that fall into that area. Nothing that falls on the dashed line would be a solution, but everything that falls on the blue line up to here would be a solution. Okay, we're going to do one more of these. Okay, our first equation is y is greater than negative x plus 4. Well, we want to graph that line, so it's going to help us to find the m, which is negative 1, and the b, which is 4. So we're going to use that information. We're going to plot a point at 4. We know it slopes negatively. It goes down 1, 1 to the right, down 1, 1 to the right, down 1, 1 to the right. I need a lot of points because I don't have a ruler. I'm going to go back up to the y-intercept, up 1, back to the left, up 1, back to the left. This line is going to be a broken line. We want to make our lines nice and long. This is going to be a broken line. All right. Now the next line is in standard form. So we need to actually rewrite the next line. So let's go ahead and get a different color. We want it to be, we've got negative, so I'm going to have to rewrite this. We want it to be in slope-intercept form. Yes, I can do x and y intercepts, but I just prefer at this moment to rewrite it. So we have negative y, and we subtract 2x from both sides. It's greater than or equal to negative 2x plus 3. And then I'm going to divide by negative 1 using the division property of equality on every single term. And so I end up with y, but now because I divided by a negative 1, my sign reverses to less than or equal to. Negative 2 divided by negative 1 is 2x, and then 3 divided by negative 1 is minus 3. So my m equals 2, and my b equals negative 3. I'm going to use that information. This is a little more involved because this was in standard form. You could, in fact, draw your line based on x and y intercepts, but I would end up with some fractional amounts, and I don't really want to have that. And so we plot our b of negative 3. It's going to have positive slope, so I'm going to go up 2 over 1, because the slope is 2, just 2 over 1, up 2 over 1. 2 over 1, and then I'm going to go back here, down 2, back 1, down 2, back 1. I think I'll go up one more time, up 2 over 1. Okay, now this is a solid line because it has the equal to sign. So you want to connect your points, make nice long lines. Again, you're using a straight edge, so your lines are going to look a whole lot better than mine. Okay, you've got 2 lines. You want to figure out where the solutions are going to be, where they're going to be shaded. So I'm going to go ahead and plug those in. I'm almost out of time, so I'm going to plug them in and just quickly go over it. Okay, I chose 0, 0 because it is not on, neither of the lines are on it. We got not a solution for both of them, which means that 0, 0 is not a solution. So my x's are above the line that's blue, to the right and below the line that's red, and this intersection here is where I have shaded And so all the points that are in there, all the ordered pairs, will be solutions as well as anything that is on this line, but not on the blue line.